We're going to move on now to our next speaker, which is Dr. Clare Goodess. So Clare was in the Climatic Research Unit for an amazing 40 years or more, becoming a Senior Research Fellow and Cruise Research Manager. She was co-chair of the World Climate Research Programme's Working Group on Regional Climate, and she's kindly come out of her recent retirement to give today's talk. Over to you, Clare.
Thanks, Tim. Can't say I particularly feel retired. There still seems to be a lot of papers and things to finish off and presentations to prepare. But actually preparing this presentation was a great opportunity to reflect and to look back and to think about all the people who've inspired me over the years, and I would say at times provoked and challenged me in a positive way. So some of the people were named there, and of course many CRU colleagues past and present. Now, because of the time constraints, I think this is going to be more of a gallop than a leisurely cruise in terms of the journey. So let's make a start. In the 1990s, and this is work that was actually led by Jean, who we've just heard from during her time in CRU. And we were a part of a small group of climate scientists working in the very much larger interdisciplinary medalist projects, European projects focused on Mediterranean desertification and land use. So we were working with ecologists, soil specialists, and so on. And I think this was a really good place to sort of start this work on developing climate projections. Because of the we had a specific application, we had a group of regional stakeholders and specific study regions in southern Spain and Italy. So I think that was a really good place to start, I would say, the sort of real work on producing information for society, if you like. And looking back on what we did, I think we were actually very innovative for the times. So you can see that. And that's even though we were only working with one, maybe two global climate models at fairly coarse resolution, not working with emission scenarios as we do now, but simply 1 times CO2, 2 times CO2, limited to 10-year time slices. And that was really a reflection of the state of the global climate modelling at that time. But we developed and evaluated a number of different alternative methods of statistical downscaling using transfer functions with large-scale circulation predictors. We thought about the problems of having information that's consistent between different variables and across different sites. So we developed some methods using Monte Carlo sampling and sort of stochastic Markov chain models. Also a stochastic and conditional weather generator based on automated land weather types, so building on some previous work in CRU. And we weren't just thinking about temperature and rainfall. Because of the desertification context, things like potential evapotranspiration were relevant. So part of the work, we developed some of probably the first projections of potential evapotranspiration using a fairly simple method, but that also allowed us to produce some estimates of moisture availability. So that was the 1990s. And in the 2000s, I think the work, particularly at the European level, which I'm more familiar with, the work on different approaches to downscaling really developed. So, for example, I led a project called StarDex into comparing different statistical downscaling methods. This was the period when dynamical downscaling using regional climate models really emerged, the emergence of coordinated multi-model simulations. And for example, in the very big ensembles project, as the name implies, there was a growing interest in building multi-model ensembles of global climate models, regional climate models, statistical approaches, both for developing climate change projections and for seasonal forecasting. And in part, this was done with the idea of moving towards probabilistic approaches to prediction and projection. But this was also a period, I think, of some quite intense debates within the climate modelling community. So, and that's kind of paraphrased in these blue boxes here. So one view, garbage in, garbage out. So what's the point of downscaling? So that's the idea that, well, if your global models can't get the sort of large-scale circulation right, whatever you do with downscaling, you're not going to improve the situation. And that's true to some extent. I mean, if the models get the jet stream in the wrong place, then no amount of downscaling is going to improve that situation. At the other extreme, and we still see this today, perhaps from some users, and particularly if they're faced with a very nice, a pretty map, there's lots more detail. So it must be more accurate. Well, the truth is probably somewhere in between the two. And I think that the added value of downscaling is a legitimate science question, hard to address when you're looking at climate change projections, which you can't verify in the same way that you can a weather forecast or a seasonal forecast. But this question is still, to some extent, being addressed. Another area of debate during this period was some tensions at times between people doing dynamical downscaling and people like myself, Phil Jones, for example, doing statistical downscaling. And at times, maybe the statistical downscaling, we were made to feel like the poor cousins of the dynamical modelers. But actually, I think what CRU showed nicely is that subsequently is that it's possible to combine the best elements of both statistical and dynamical downscaling, particularly when you're interested in producing probabilistic information for risk assessments. So a lot of this work was done in the context of, it was actually funded by the Engineering Research Council in the UK, focusing on different aspects of climate change and the built environment. So, and a lot of this work built on the CRU weather generator, but looking at how you can actually perturb that by taking change factors from regional climate models. And in fact, some of those regional climate model simulations were some of the first simulations by the UK Met Office, kind of attempting to include some estimate of the urban heat island and how it might change. And so information that CRU produced was used by colleagues from the Tyndall Centre, for example, to look at urban heat and flood risk, particularly in London. We also use these outputs for some very specific applications in developing design summer years. So design summer years are what the building community engineers use to assess the risk of buildings overheating. So we were providing information for the future in exactly the same formats as the design summer years that they are sort of obliged to use when they test and evaluate buildings. And this little schematic will kind of shows the sort of process of taking the RCM change factors perturbing the weather generator. Of course, one of the advantages is you can run the stochastic weather generators as long and as many times as you want, so you can end up with very large samples, which should give you more robust estimates of the rarer extreme events. And this little graphic on the left-hand side is actually a cover from the UK Climate Projections 2009, which incorporated the CRU weather generator as one of the tools. So, well, maybe this is a bit of a self-critical question, and I guess it's a question not only relevant for CRU but for others. So we've contributed to many climate change portals and tools over the years, but how many were never used? And that might be for very practical reasons, because they were developed during a short funding project, the funding ended, because the users were unsupported, particularly after the end of the project, but more seriously, perhaps because they never provided what users needed and were able to use. But maybe, hopefully, the example I've given you here gives a bit more positive spin on this. So this was a project funded by the Climate and Development Knowledge Network, the CRU50 project, where the team in CRU worked with Caribbean researchers and users And so one of the things that's provided through the CRU portal is a version of the CRU weather generator. And I think the reason why this was perhaps more successful than some of our other work is because the ongoing capacity building and training in the use of the tools, working with decision makers in the region, was provided by the 5C Centre, the Caribbean Community Climate Change Centre in Belize. So maybe CARIWIG was an early example of a successful climate service. So climate services have kind of exploded, I would say, over the last 10 years. Jean gave you one definition. Here is a definition on the left-hand side from the WMO Global Framework for Climate Services, which was launched in 2012. So different words to the European one that Jean showed, but essentially sort of saying a similar thing. But on the right-hand side, I mean, this is perhaps how I kind of prefer to see the world of climate services in a bit more of a visual way. And so it's thinking about how do we get from the world of the climate modelers, so that that kind of CMIP graphic, 1 minute, okay, is I guess where a lot of my CRU colleagues have worked. So the world of terabytes, NetCDF, how do you get to climate information, which is being used by users who are not only using climate information, but a lot of other things as well. So this was perhaps my first experience of working in something that was actually called climate services, developing initially a pre-operational service for the European renewable energy industry. I'm probably going to have to skip through this because I've had my 1-minute warning. So, but again, I think this emphasizes a lot of what Jean was saying about kind of partnerships, about listening, about kind of understanding, developing relationships, and the fact that it takes time. And I think a more recent project, the Seckley Firm project, focused on seasonal forecasting, really helps to emphasize this. So here, there were a number of case studies that focused on very specific decision-making contexts. Each of the case studies had an industrial and a research partner. And it became kind of very clear that you can't separate the user needs, what's useful and usable to them, and their decisions. And what we might have done 15 years ago, just sending out a questionnaire at the beginning of the project, is not appropriate or effective. So again, emphasizing Jean's point about this not being a quick process. And the little example there is we developed these decision trees for each of the case studies. This is one focusing on offshore maintenance, focusing around ship hire. And here the point is what the users actually need information about is offshore winds and waves, so not a kind of standard variable. Okay, I'm definitely running out of time, so I'll kind of skip over this, which is talking about different scales of modelling and the different mix of models that kind of Tim sort of referred to, that we have a lot of potential modelling tools, but users need guidance about how to kind of use these. And there are a lot of research and science questions about optimal nesting strategies, of regional models, regional climate models, the new convection permitting models. If you're interested in urban areas, how do you bring in urban canopy models, for example? So this is all about a trade-off between high resolution and ensemble size. I'll skip over that. And this was just a final slide thinking about some future opportunities for CRU in the context of climate information for society. We've all talked so far about projections, but observations are absolutely essential for validating models, for post-processing, for statistical downscaling, and so on. The understanding of physical processes that CRU now has great strengths in climate dynamics, which we heard in the last meeting. At the same time, colleagues are developing innovative machine learning approaches. And what for me is really exciting is that these two are not kind of mutually exclusive. Machine learning now doesn't have to be black boxes. CRU can bring insights from different timescales, both past and present, seasonal, climate prediction. We're working in an interdisciplinary environment, which is really important when one thinks about co-production. So within the School of Environmental Sciences, Climate UEA, we have access to social scientists, for example. Strong stakeholder linkages, and thinking about kind of going forward, the new generation of embedding and mainstreaming climate expertise. We have the undergraduate MSc and of course the PhD students, and I'm really looking forward to the presentations after the break from students. So yeah, that was definitely a very fast gallop. So thank you.
Thank you, Claire. We will see if they have any questions online at all. We do. Perhaps over to Emily.
Hi, can you hear me?
Just.
Yeah, we have a question from Jean online asking how you measured the success or performance of the CRU50 project.
Okay, I mean, to some extent that was kind of taken sort of out of our hands, because so the kind of whole process and the training now is being done by the 5C Centre in Belize. But I think, but they continue to be active. They continue to seek sort of funding. So, for example, they got some funding to produce some videos around the use of the tools that were co-developed with users within the region. And I think one thing that 5C's focused on was training the trainers. So particularly in an area like the Caribbean, their remit covers a number of islands, some of which are kind of really small. I mean, some of the Met services on some of the smaller Caribbean islands are literally a handful of people, maybe even one or two people. So kind of training the trainers, but also they have really good contacts, a really good regional network into local agricultural organisations, hydrological organisations. So I don't think for that project there are no kind of formal performance indicators, for example. But I think it was having that agency kind of on the ground who had spent years building the trust. And I think that's something that's really important as part of this thing about usability, of things being credible, salient and legitimate, and building trust.
Thanks, Claire. That was a really interesting question and answer.